Hello again, engineers. We're back for another one. At this point in the series, we'll begin to slow down a touch compared to the previous ones. That's because, largely, the first three sciences are very quick to set up with most any basic setups that we can do. But now that we're beginning to unlock some more pertinent technologies, we are faced with some more mid-game optimizations that we can make, as well as really start to personalize our factory to be more suited to us. We do, of course, also have to deal with our more aggressive neighbors, who are definitely beginning to get bolder by this point. After our gift to the environment continues to spread, our neighbors graciously take our gift, roid up, and come to aggressively ask for a cup of sugar. They usually take 5, I think the cup measurement is foreign to them. So to start with, we go around and clear out a couple of nests to make sure our time is a bit easier. This is a time that's worth mentioning. You can add waypoints to your map very easily. A simple Alt plus right click will place a marker on the map, and you can do this multiple times. The best part, it queues on the right in a stack from top to bottom, which you can then follow along, check things out, and then delete as you complete these destination tasks. Very handy when you're wanting to get some tasks done that involve travel, very easy to keep yourself organized and on task, and you can also rename the tasks, but they default to a grid coordinate, which is also very useful. Absolutely recommend using this if you keep getting sidetracked. Once we finish clearing out that initial bit, I realized just how roided up the neighbors have gotten, and I decide to increase the quality of the sugar I dispense to the neighbors, hoping that a more name brand packaging will discourage them from asking for more out of pure shame at the cost, like any decent American neighborhood would feel. But that's not important right now. What is important, we need to move on from the basic oil processing of last video, and embrace advanced oil processing. It sounds frightening, but it really isn't too bad. It simply adds on one additional input and gives us 2 additional outputs. We also get way more bang for our buck on the crude oil, and water's free, so that's nothing but a win to us. So, naturally, in order to make this change, we have to research the requisite tech. This will also include lubricant, not for the reasons you think. On top of our desire for more varied oil products, we also want to solve the #1 issue present to Factorio: loneliness. It's an epidemic, and fortunately, Factorio has the vaccine. Drones, beautiful, magnificent, labor-freeing, unpaid, unrelenting, and most importantly, very cute sounding. That sound, however, you're not allowed to hear it until you've made them. That's your reward. But before the magnificent dream can be realized, we must first process the necessary pieces to achieve life. And life, of course, begins with lubricant, which is facilitated by advanced oil processing. So is it frightening? Absolutely. But will your children thank you? Maybe. But that's not important right now. To begin with, we will remove the old oil refineries. They were weak and are useless to us now. Now we manifest a new system, one that is beautiful in its simplicity, but complex to the Factorio-fearing eye. To start, we handle each of our liquid outputs and inputs. Notice the placement of these underground pipes. Don't skip this step. This is important to keeping liquids separated. We then get one side prepped and then copy the refinery to the top. We then do something truly amazing since Factorio 2.0 released. We flip the outputs and inputs horizontally to match the lower refinery. We achieve this with the magical H key, matching up the pipes perfectly. And then we just copy these blocks across, and there we have our liquid routing. Simple as could be. A couple of liquid tanks later, and the first stage of oil cracking is done. And then it's just a matter of assembling the blueprint, and done. So it might have become apparent at this point. But in case it wasn't, our current oil patch is, well, not enough, which is why we need to bring in more oil. And though running a massive pipeline from forever away may seem like fun, I can assure you trains are way more fun, and once set up properly, will change your life forever. A lot of engineers' first trains are what's called a push-pull train, or a bi-directional train. This is because those trains possess two locomotives facing opposite ways on a single rail. While there are some advantages to this, there's also a number of disadvantages that come with a train system that uses this more simple logic. For our purposes, we will be using a monodirectional or one-way train. Because of this, we will also be adding in a two-rail system in order to improve our throughput later. This is our future-proofing at work here, but we'll start with a simple implementation of the trains. Alright, hey, future me here. I don't know exactly what happened, but the section where I actually built the rails out and thought that I was talking about the trains themselves kind of got corrupted. So I'm going to do my best to explain what I had tried to explain then in a very brief but concise way. Basically, we have the option of bidirectional trains, such as this. And the way that that works is that essentially you've got a train that can go in two directions. Let me see if I can add some fuel to it here. Two directions at kind of equal paces. Like so. And most players, when they start with trains, will do a single rail like this and have it just go out, point A and point B. And while that's fine, we instead started with a monorail, pretty basic, just one locomotive and one wagon, and it's going to go along where all these signals are laid out. These signals restrict everything to a single direction. And I'm doing right-handed signals because I'm American, and I don't know of any other way to do it. I'm very set in my ways. But the biggest thing was we set up our train stations with an oil drop and an oil pickup, each in their own respective locations. And we're going to get into this. We're going to drive the train to show you kind of how a basic train setup works, if you haven't done this before. So clearly how I have it set up here is we have the oil drop, which it goes to by clicking on it. That does automatic. And it comes over and it stays here until it is completely empty. Notice it's not going to the oil pickup right now, and that's because the destination is considered full. I'm going to explain why by manually holding down left control, and we're going to left click to set a temporary stop up here. And what's going to happen is you can see here it made a temporary train location, and it's going to wait for 5 seconds. I'm going to turn it to manual so that you can kind of see what's going on here. You can see here the train will automatically go to the location that we specified. It's going to pop right there, and then I'm just going to hit manual. And I'm just going to sneak a little bit of oil while we're here. Because why not? So this is where I was supposed to talk about a basic logic setup for limiting your train network stuff. And of course it got corrupted. So let me re-explain it again. Basically, every oil outpost that we'll set up in the future will have a setup similar to this. A couple of tanks, a couple of wires. The wires go to a combinator or a set of combinators. This one's just very binary. All we're doing is we're taking the amount of oil and dividing it by 50,000 and outputting a signal of L. So why are we doing that? Well, every fluid wagon has a total capacity of 50,000. So what I'm saying is each of these liquid trains hold 50,000. So when I have enough to fill one train, that is when I will change the train limit to accommodate that. So right now the train limit is set to 0. But you can see I clearly came in and cheated a little bit to extract this oil. So even though we can't actually have it come and stop here, we did get the 50,000 it would have been able to stop here. And we want to do this because we're going to end up having 1, 2, 3, 4, 5, 6. I mean, 6 and going on more oil stations in the future. This is just kind of a future-proofing thing, a very simple logic setup, and you have to come over here and click on set train limit to do this automatically. So you don't have to do this step. It's totally fine just to do the simple oil drop, oil pickup, empty and full cargo, because it will sit here until it's full. But this is just to kind of show, hey, you can do what you're going to do later, most likely anyway. and then we'll just set it to go back over to our drop-off. And when this is empty again, it'll just show that it can't actually reach that station. And I spaced out all of these signals for a one wagon, one train, one locomotive, excuse me, setup. Again, not entirely necessary, but just something that I like to do to kind of future-proof things. So yeah, we'll see right here, predictably, this will completely empty out the tank. And then instead of going straight to the next station, it will have this little Z icon. And when you look over here, it'll say destination stop full. That is a normal response. We're not going to get into train interrupts and all that because that's going to kind of be worth its own video explaining some of these things, but basic train setup and what I was trying to explain before right here is oil drop, oil pickup, we rename. This is where we drop off the oil, obviously. This is where we pick up the oil. A slight little logic circuit that sets the train limit and only requests the train when there's a reason to come and actually pick something up. So I hope that sort of explained it. If you need a little bit better explanation, I will try to do it better for the next one. But suffice it to say, this is a very basic train setup that we will be able to scale later on. So with the trains complete, now let's focus on the truly horrific topic of oil cracking. Don't start shaking yet, it's not that scary. Remember when we unlocked advanced oil processing back, a few minutes ago? Yeah, it happened. And that gives us 25 heavy oil, 45 light oil, and 55 petroleum. Notice something? That's not even. And we eat petroleum like we're addicted and showing absolutely no remorse. So here's what typically happens. You burn through petroleum, light oil backs up first. Once light oil backs up, the refineries can't output light, which means they can't output heavy, which means they can't output petroleum. And suddenly, everything just stops. Oil doesn't really fail loudly, it just kind of quietly strangles your factory until plastic dies. Then red circuits die, and then you die inside. And this can happen with any liquid backing up. So, cracking exists to solve that imbalance. The common solutions most players go are one of three routes. The first one is to just crack everything. And for that example, I'm actually here controlling everything post-production here to kind of show you an example of what that looks like. And essentially, we would just take a little setup like this. Right? You have like 3 here, and let's just say 3 here, and you would simply set your recipes as following, where you have the heavy to light, and then you'd have the light to petroleum. And you would simply just do this all the time, and you would then feed this coming on up and over as such. Although not exactly like that. Let's not be silly now. Obviously it would go into the correct outputs. And then from that output, we would then go from here on down. Something stupid simple like that. Ooh, too far. Okay. So, this is a simple way to do it. It works early on, but the second that you're going to need your lubricant, that's when you're going to have actual problems, because you won't be able to keep a valid stockpile of it all. The second one is tank threshold pumps. Now, essentially how this works, you see I've got some pumps up here, but essentially how this would work is you would just have some basic pumps. So let's say we have these pumps here, representing our heavy and our light oil going out. And you would then wire these and pretty much give them something like, let's say if heavy oil is greater than, I'll just say 20,000. No, not 20. That's a stupid number. 20,000. This would then turn on, right? So if I just give it some power here, and then I were to hook this up, like so, you'd then see little signal on there turns green, and it is now working. If I were to disconnect this, it turns off. I can do the same thing over here, but for light oil instead. Now, that works. It's better than just cracking everything at any given time all at once. But it's largely reactive. It waits for the heavy oil to fill, and then you have all this heavy oil that's just not getting used, basically. Which you could argue that things aren't getting used right now as well, but that's just because we're in a state of non-active working. But the biggest thing is that having the two sets of chemical refineries can take up a lot of space, and it can feel a little sluggish. The third one, and the one that I've used quite frequently, is to do a fluid bus design. Basically, we treat our fluids like they're on a belt. You've already seen a little bit of that sort of in action with some of this here. But as an example, let's just say that we came over here with our plastic line as an example, and we wanted to run it like a belt. You would essentially run pipes going up like so, and then at some point you would then pull from the bus going to something, and this would take the priority over whatever else comes down here. Then you would reach a point, which we can still represent that with a tank. So this tank would represent our fallback point or our overflow, and then this overflow is the one that would actually be cracked into the next thing, more or less. Now, that's a very common way of handling it, and I did that for hundreds of hours with no problems whatsoever. But again, it wasn't reactive enough for what I wanted. So, what I'm about to show you is something that we've designed that allows us to take more control of our actual factory. And excuse me, the whole time I'm recording this, I am just coming out of being sick, so you might hear my voice crack more often than normal, and I'm not going through puberty, I promise. Maybe a second puberty. It could be happening. So, what are we doing here? Essentially, we are going to do something that is more of a dynamic setup. Let me see if I can explain it well here. I have some notes written down here. So, we're going to control this basically like we have modes or states. I call this a state machine. It operates on a similar principle to a state machine, but there's some key things to go over before we actually continue. The first stuff is, how are we actually able to do this to begin with? So we look at our chemical plants. You'll notice I can't actually change the recipe on these manually. That's because when you hook these up to circuits, there's a couple options over here, and the key one is this little set recipe bit. What that essentially allows us to do is we could take something like this constant combinator, and I could just pass a signal across here. So, were I to pass a signal, let's just say, let's do something that's not related. Something that a chemical plant can do. Something like plastic. You see that? When I pass the signal, it then goes to every one of these and changes what the recipe is. The reason I'm doing plastic is because it is not related to this. Because if I do the wrong signal at the wrong time, we'll start an artificial inflation. Which isn't necessarily bad, but we want to kind of keep the state of things semi-flowing over here, as much as we can. So, this is just to show you this is how we're actually controlling it. Take it away, signal's gone, it all goes away as well. The other important thing to note is that when you're dealing with your combinators, you have green and red wires. You'll see an example right here where I'm using two different ones. It doesn't actually matter which one you use. But what does matter is that they do keep separation. And what do I mean by that? Well, I'll explain it a little bit more here in a bit, but right here you can see our input and output, and I've got a green output from this one, but I also have a red output that's actually feeding into the input of this second one. I'll explain more about this later, but this is a concept known as signal separation, and it's very important for a lot of systems that you'll do later on. So, now that I've kind of explained some of that top level bit there, let's get down to the actual explanation here. So, what exactly are we going to do here with these modes? Basically, we're going to be in one of three modes, or states. I'm going to refer to them as states because it's easier for my brain. First state is that we need petroleum, or we are low on petroleum. Second state is that we need light oil, or that we're low on light oil. The third state is that we're not actually low on either of these and we have an abundance of both. We're going to call that the neutral or the reset state. So, surface level, that's pretty simple. And in reality, it is just that simple. There's a couple little caveats, that kind of go with this, but we're going to translate that into basically an analog program here. And it's going to be pretty easy to follow, don't worry, I'll stay with you the entire time. The biggest thing with this is that we're not going to allow both cracking recipes to be displayed at once, because there's a couple things that'll happen with that. One of them is that whenever you have two signals at once, one signal will always take priority, and it may not be the signal that you want. I did a little bit of testing with this, and I did find out that the heavy oil to light oil recipe signal was taking priority over the light oil to petroleum recipe. I don't exactly remember the why. It's something to do with the back end of how it's organized in the file system. But suffice it to say, even if it were to not be prioritized and the other recipe would, we would still want to do this as a best practice. So, let's get into it here. Petroleum has the priority, of course. So, right here, we're going to say, if petroleum drops below 75,000, we're going to output the recipe for light oil cracking to petroleum gas. Right? That's pretty simple. When we get low enough here, we're then going to turn these machines on to pull from the light oil in order to feed this at a higher rate. Simple. Very simple. So what's the complication? Well, we're sending this signal out on the green wire, which you can't see anything because there's no output right now. And these are input signals. So obviously this isn't true, so it's not sending anything out. But if it were sending anything out, it would follow along this green wire going here, sharing its output if there is any, and then sending the output up to the machines and over this way, which we'll talk about that in just a second. But we're also sending an output signal on this red wire as well. And this red wire is going to the input of the second combinator. So why is this important? Well, it's only important because on this one we're checking not only for the level of the light oil, which is about the same as the petroleum, we're also checking if this signal, the light oil to cracking, is not equal to 1. Why are we checking that? Basically, we're saying, is this currently requesting petroleum? If it is, we don't want to turn on the light oil cracking because it will take priority, but also because we clearly need more petroleum than we need more light oil. So we don't want to try to get more light oil, we want to try to get more petroleum. That's our main product right there, especially early on. If both of these are true, only then will this output true. And this is what's called a priority gate, basically. We make sure that petroleum gets its cut first. As long as petroleum is happy, then we can make light oil happy. So, that handles up here. But what's this nonsense going on over here? Let me come around here just to get a little better look at it. This nonsense going on over here is our plumbing system, essentially. So, let me just kind of look over at my notes once again here, just to make sure. So we're going to call this the control layer. So as you can see here, the green wire does a couple things. First off, it's going to travel to these two pumps first. This one and this one. Notice that both of these pumps are facing in. They're pointing their arrows directly into this pipe system. And where does this pipe system go? You can follow the gray lines to see that it goes into the input slots of each chemical plant. So, these ones are being controlled by the same signals. So, if we're wanting to crack light oil to petroleum, we need light oil, right? So then we turn this on to inject light oil. And then subsequently, if we need heavy oil to light, obviously we need heavy oil to come in. So that does the same thing there. So why am I doing this nonsense then? Well, for one, we need to do some signal separation and some control signal handling. So what we're doing here is, instead of going off of the recipe things, because recipes won't really help us with this the same way, we're going to come in here and we're going to clean the signals. And to do that, we're simply going to take the heavy oil to light. If that's present, that means that light oil is something that we want present in the system. If we're doing this, if we're doing this light to petroleum, that means, well, okay. Let me try this again. Heavy oil to light, we want to get light oil out of the system. Light to petroleum, we want to get heavy oil out of the system. I explained that perfectly, and I know it. So, we then come up here, and what we're doing here is we're actually going to flip these signals. So if heavy oil exists on here, we're going to flip it over to light. And if light oil exists, we're going to flip it over to heavy. Why would I do that extra step right there? It's kind of pointless, right? Well, except that it isn't, because I already have to do this. This magic thing is our actual neutral state. This is where the real magic happens. What I'm doing by flipping these signals is I'm first off separating the signals from going straight to the pumps, and I'm feeding into an actual control logic brain, which allows me to set these states for the actual plumbing bits. So we have the states for the chemical plants, but then I need states for the plumbing system. So when this is outputting as light oil as a 1, let's look over here at what this is saying. If light oil is 1, that means that we want to drain the heavy oil out. If, over here, heavy oil is 1, this means we want to drain the light oil out. In this case, both of the signals are actually generated, because both of these are 0, meaning that we're in our neutral state, and we are now able to empty the pipes completely. Why would we want to do this? To put it simply, we just want to put it into a neutral state that makes it very easy to rapidly insert the correct material and then get the desired material out fast as possible when we're in a neutral state. Is this necessary? Absolutely not. You don't need this. You don't need this at all. But here's the thing, why would we go this far to set up something? Because this is pretty intense. We just did like a little, very, very raw, crude state machine, right? Why would we do this? Well, it's quite simple. We did this because this allows us to have more control over the factory. This setup enforces priority automatically. It prevents us from cracking both recipes or attempting to. It actively cleans this pipe network, but the most important thing is that this is teaching you how to build a state machine. And once you understand how to build something like this, you can then use this to control trains, you can control power grids, you can control nuclear systems, megabase logistics, all because you learn how to take this simpler setup of oil and advance it. Evolve it, basically. You don't need this to beat the game. Tank thresholds are fine, overflow designs are fine, but if you want to control instead of just react, this is how you do it. One state at a time. You commit, you control the flow. It's just as simple as that. You don't let the state of the fluids themselves necessarily control you and bottleneck you. You decide what to do with the fluid states on your own automatically. And that's a very powerful thing. Alright, so today we did two very important things. We didn't just place rails, we didn't just unlock oil. We changed how the factory thinks. We moved from make thing, hope it works, to design system, control the outcome. We set up trains the right way, 2 rails, 1 direction each, even though we only have 1 train right now. Why? Because we're building for the factory we will have. not for the one we currently have. And then came the oil. Advanced oil processing is usually where newer factories start to choke. Fluids back up, plastic dies, production stalls. Instead of reacting to that, we built a controlled system. Priority states, mutually exclusive cracking, pipe isolation, hard resets. And more importantly, we used combinators to make decisions for us. That's the shift. This is the point in the game where you stop playing manually and start designing logic. From here on out, the factory's not just expanding, it's evolving. Next episode, we're going to take advantage of what we unlocked today, because now that oil is stable, now that trains are structured properly. Next episode, we're going to take advantage of what we unlocked today, because now that oil is stable, now that trains are structured properly, and now that you've got your little robot buddies starting to tag along with you, we can scale. And when we can scale, we don't want chaos. We want control. Thanks again for watching. I've already taken up way too much of your time. You know the drill. Get playing. I'll see you in the next one.